Google Classroom, right? I have some announcement, basically just a repeat of what I've shared in the classroom stream. But seems like Farah not in yet. Let me message them. Let me just message Farah. Right, so I'll repeat the instructions later for Farah. Message him already. Okay, so as you see in the streamer, I'm just gonna go through it again. Okay, so the question paper will be released between 7:55 and 8 a.m. Why there's a range? Because Google Classroom is not, as I say again, not very accurate. So at 8 o'clock, you will start answering the questions. You're given 1 hour. So from 8 a.m. to 9 a.m., there will be 2 questions. Each question is 25 marks. And so together will be 50 marks, right? It will be scaled to 100% for this part of the coursework. But of course, it will be scaled again because it is only part of your coursework, right? So at 9 o'clock, you will start writing and your answer, and you are given 15 minutes to submit your answer. Right, so you use A4 paper or foolscape paper to write your answer. Okay, and when you're done, and before you submit, you will use your app from your phone, something like a Cam Scanner, for example, to capture your answer and then compile it, using the app, save as PDF, and upload the PDF into your submission in Google Classroom, right? This Google Classroom section for submission will appear around 8 o'clock together with your question paper. Okay. All right. So if you submit late, there will be penalties here. So as you can see, if you submit between 9:16 to 9:45, automatic deduction of 5 marks. If you're late more than that, that means 9:46 onwards, you'll get 0 marks for the e-test. All right. So I remind that please do not plagiarize. Okay. Among each other, also for do not do copy paste. Right. It's open book, but please no copy paste. Any questions? Yes, we will answer. You will write your answer using A4 paper, foolscap paper, right? As long as the legible, yeah?
Foolscap paper?
Yeah, you can.
No,
Foolscap paper.
not type,
Handwritten.
not type in the Google Doc. Right?
No, handwritten. This is consensus from all the,
Yeah.
yeah. So later when you're done, you will use app like Cam Scanner. You guys know how to use, right? Ever used before? Cam Scanner, right? Or Office Lens, right? You can then take screenshot of using your phone, yeah. Capture the screenshot of your each page, okay? And then you compile it. The software is able to compile it into one PDF document, and rename that PDF document using your own name and submit that, okay, into the Google Classroom. Is that okay? You guys know how to use Cam Scanner, right?
Oh yeah.
Anybody? Anybody can access what not?
Access.
Hmm.
Oh, I see it.
See what?
Uh, you guys have spoke to Farrell. Does he know about the test today?
Not sure. Already sent him
Because
a message.
I imagine I did remind you guys, and also there's a announcement in our Google Classroom, right?
Oh yeah.
Where the question paper?
You got already, yeah? Both
No.
Kelvin and Noel?
Oh, I don't see the question paper.
Not yet. Okay, can you please wait until 8? Because this is Google, that's why we put a range 7:55 to 8. Google is not very accurate in this. I'm unable to contact him. I call him, but no answer. So I have no idea whether he knows about the test or not. You guys have any inkling? Does he know? You guys talk to each other?
Oh yeah, but no reply.
Okay. So how you guys know? You guys know from the classroom or when I mentioned it also, right?
Classroom. Okay.
Has the paper been released? Noel, Kelvin?
Ah, yeah.
Okay, you guys can start already, yeah? Anything, please inform me. I'm monitoring, yeah? Oh, by the way, can you guys switch on your webcam? Nearly forgot. Switch on your webcam, man. Noel, can you switch on your webcam? Okay, thank you. Hello, Noel. Can. There's a rule unless the question asks you to give the name fully, yeah, then it should be all right to use the acronym. Hello, Farah. Quickly, you can still do. You have about 35 minutes. Okay. Uh, very quickly do it lah. Okay. Right. So you should be able to get the questions from our Google Classroom. Okay. You can use Farah. You can use A4 or foolscape paper. Write your answer manually. Okay. Written test. Yeah. You write your answer, and then after 9, you can use Cam Scanner to take a picture. Okay. Compile it, submit as PDF. So okay. Farah. All right. Any question on monitoring? Yeah. Let me know. Yes. Also, can you please switch on your webcam? Okay. Fair. Okay, 15 minutes left, yeah. Right, so 9 to 9:15 is time for you to upload, yeah. Okay, just a reminder, you should start to submit already, yeah? Okay, as long as you submit before 9:16. So if you submit by 9:15, no marks deducted. If you submit after 9:16, 5 marks deducted, yeah? Yes, go ahead. Just a reminder, I haven't seen anybody upload yet. It's 5 minutes left. Uploaded, huh? Let me double check. Yes, I can confirm. Lowell uploaded already. Okay, 2 minutes left. Calvin and Farah.
Done. My handwriting is very bad. Hopefully will hopefully you can read.
Okay, let me check here. Should be
My handwriting very bad.
I can read it. That's all right. I can read it. Okay, can I confirm, Kelvin? You have answer itself is 2 pages, yeah?
Yeah.
The first page is blank, yeah? I confirm. Okay. All right. Just want to make sure the first page is blank or not. Okay, Farrell, let me check yours, yeah. Okay, I confirm also. Farrell also is 2 pages. And Kelvin also 2 pages answer, 3 pages altogether, but the first page blank. Okay. All right. So all submitted already. Thank you very much. Okay. So we go for a break before we start again for our lecture. Is that okay?
Do we use this link or do we use another classroom?
We use another link.
Okay.
All right. So we'll give you about maybe 20 minutes now. Huh? Break. So okay.
Okay.
All right. 20 minutes break. Yeah? All right. So we use the other meet. Okay, this one you can leave this meet. Thank you, everyone. All right. Hope you have a short break just now. Okay, after doing your tests. I'm pretty sure none of you have breakfast yet. Very early, yeah. Okay, so I think you know, because we are actually having a simultaneous test across Malaysia, lah. Okay, other branches including main campus. All right, that's why to find a suitable time is very hard. So everyone agreed for the 7:30 at 7:45, 8 o'clock start now. right? Okay, so let's continue with our lecture this morning. So I'll start by I'll just present my screen first. Okay. Right, so I'm just going to remind you guys that we are in week 7. Okay, and please be aware that the next incoming test that you have is the SBA, right? The skill-based assessment, all right? So that will be, I think, week, I'll have to confirm because it's not shown here. I'll have to confirm with you guys. Oh, here, sorry, shown here already. So this week 12, you can see there, right? There is an SBA revision here. Normally, we will do revision a week before the test itself, right? Okay, so be watchful of that. So that means SBA is basically the packet tracer test, yeah. Okay, so normally what you get is the packet tracer, and then you are supposed to do some configuration there. Okay. All right. So and also it will include the topic of subnetting and VLSM. Right. Okay. So this week we're going to continue the second section of the chapter 7. Okay. This chapter is very long, so I don't want to rush through it. Okay. So, but be assured that we'll try to make up here around here subnetting. Okay. When we do subnetting. All right. So when we start to end the lecture, let me record our meeting. Okay. We stop here. Basically, we stop at the video, right? And then this section, we have two slides, okay, left before we move on to IPv6. So let me just finish up on that. We started to look at classful IPv4 addressing. Here, basically, we just expand it, right, by showing you that chart is basically showing you the differences between all the classes, okay, and percentage of the address taken up by that class, okay. So as we know before, class A, we have more addresses, host addresses, because we only allocate 1 octet to the network, right, to the network portion. Class B has equal 2 octets for the network, two octets for the addressing. So it has less address but more networks, right? And then class C, you can see we have 3 octets of the IP address reserved for network, and then the last octet, 4th octet, used for host addresses. Now, in the classful address, right? Classful address, we don't have any in between, just because the boundary is always at the dot, right? So we either have for the network portion 8-bit, 16-bit, 24 bits, and nothing in between. So to match your network design with the classes is very hard. So you have to either choose A, B, or C, and this is very wasteful, right? So it's very wasteful. Thereby, after they think about it, they're seeing that we are wasting the IPv4 addresses. Furthermore, we are going to run out because of, as I mentioned before, the growth of the internet, whereby there are many, many more devices connected to the internet, and the advent of nowadays, with the advent of IoT, IoT devices, the lack of IPv4 addressing is even more crucial. So they move on to the classless, addressing, and this introduced somewhere within the 1990s. It's not like a specific date, but they talk about it and they design it and then they introduce it. The classless addressing basically allow networks to be in between of classes. So if you don't really want class A, you don't really want class B, but you want something in between, then you are allowed to now divide network and host at any bit point, rather than exactly on the dot. Okay, we call this the classless interdomain routing, or CIDR. Okay, the acronym is pronounced CIDR. Okay, you can see here, right? So that means now it's becoming, the way we assign addressing is now more flexible, right? So the bit boundary is not only on the dotted place, but can be any bits, right? So this is what we are using now, the classless addressing. Okay, so moving forward from now, once we move into subnetting and VSM, we'll be looking at classless rather than CIDR. Okay. All right. So this slide shows you the division of global division in terms of apportionment of IP address. So there are 5 major registries in the world. Each registry is in charge of the area assigned to it. So you can see North America is ARIN, South America is like NIC, European, including Russia is RIPE, and Asia, including Asia Pacific, is APNIC, and Africa, AFRINIC. Okay, so they are given a range of address, and it's up to them how they portion these addresses to all the countries, countries inside their region, and within the country itself will portion to the ISPs. Okay, so if you check online, you'll see that all regions have exhausted their range. Again, this is very crucial, but it's still all right for now because they can reuse, and they use the private and public. They play around with the private and public addressing. Okay, hiding private addresses behind the network address translators. Okay, so by doing this, they are able to sustain for now, right? Okay, so it's not sustainable for long term. Okay, that's why we are already in the process of transitioning into IPv6, right? So that's the topic of the second section of our chapter, which is the IPv6 network addresses. Okay, so even though it's not globally, it's not fully used, okay, has not fully replaced IPv4, but because this is the future, so we need to know what is this IPv6 network addresses. Okay. Right, so we repeat here the need for IPv6. So when we compare IPv6 versus IPv4, okay, we look at the bit space. IPv4 as in terms of bits, is only 32 bits. We already see that it's roughly around 4 billion addresses, but even that seems a large number, but it's not actually. It's not enough. So when they come up with IPv6, they make sure that the IPv6 will have a longer time. Okay, compared to IPv4 in terms of being used. So IPv6 has 128 bits. All right, so that's about 340 undecillion addresses. So we're not very familiar with this measurement, but if you want to check it out, just use your scientific calculator, do 2 to the power of 128. 2 to the power of 128, and you'll see what is this undecillion. Okay, how many digits behind it?
Will all the IP4 eventually become IPv6?
This is the plan. If they can help it, I think they want to straight away convert, but we cannot force people around the world. Okay, when I say people, consumers, government, organization, large corporation. The reason why, because IPv6 must be supported both in hardware and software. So software, I believe, shouldn't be that much of a problem, but the hardware. So the hardware, if you for small organization or small company, maybe the cost is maybe okay lah, they can afford. But when you are an enterprise or organization where you have a large number of devices, to upgrade in one go is too prohibitive in cost. So they take phase. They want to transition, but they do it phase by phase lah, depending on their own timeline. And also, some parts of the world, they are still using old devices, maybe only supporting IPv4. If they want to use IPv6 again, they have to basically convert into new hardware that is supporting IPv6. So we give them time. I mean, we cannot force them, so we give them time. As long as they understand, if they have sooner or later they have to convert, so that they're not left behind. So I believe most of the world do think about this, do want to transition, but depending on the timeline lah, they have their own timeline and their own budget. It's not an easy task to, for example, even talk about one state, let's say in Sabah, or one district, to enable everyone to transition. So the ISP plays a large role in this. But again, we cannot force them. If you think about other countries, phones already you can buy phones now. Most modern phones, smartphones, already come with 5G. Why? Because a lot of countries now started to roll out their 5G. But Malaysia, think about it. Malaysia just announced they're going to focus on 4G. 5G is only going to be introduced 2 years later from now. So you can see, even though the technology is there, but it's up to the commitment of organization, commitment of the government. For why I say government? Because in our country, for example, one sole communication company controls everything, which is telecom. So the infrastructure mainly being done by telecom, of course, because I think they are operated as a profit company, but they rely a lot on the government, okay, for access to do the infrastructure, things like that. So when the government say, okay, 2 years later 5G, then you have no choice. You buy your phone now with 5G also, you cannot use. Okay, so this is the same with IPv6, right? From our point of view as technologists, we say, oh, it's good. IPv6 should replace IPv4 already. But again, there's a lot of reason why it's very slow to transition. Now the thing is, even during the transition, people are having both IPv6, some IPv6, some IPv4. So it's good that network layer is able to run both protocols together at the same time. They don't interrupt each other. Okay, and that is why under the data link layer, there's a field in the frame that you can set whether the PDU, the frame contains the data of IPv6 or IPv4. For example, later we'll see three major ways that the transition is being made between IPv4 to IPv6, right? So here are some reasons. We talked about it already. Rapidly increasing internet population. Right nowadays, I think it's very difficult for you to find any country without internet. Okay, remote also you can access via satellite. I think with Elon Musk launching his his satellites. Do you guys know about it? SpaceX is launching, I forgot what's the name of the satellites, but Elon Musk is hoping to cover the entire global world with satellites that provide internet access. So places where you don't have investment by the government in terms of infrastructure for cable or landline type of network infrastructure, communication infrastructure, then I think that's where Elon Musk is hoping to make his money, right? So even Malaysia, you can already start to pre-order, because the coverage. But I think Elon Musk will be able to do it because he has his own space company, right? Rockets and all this, right? So even, and if you think about that, that means even now inaccessible places will be able to access the internet. So again, that adds on to the current population of the internet, right? Depletion of IPv4. As I said before, all 5 regions already depleted their range. They're now reusing, and coming to the third point, they're using NAT. Okay, they're using more and more private networks and using the network address translation to basically convert between private and public. There are issues with NAT as well. Okay, and they hope to fix these issues because it's NAT is, the thing is when you scale up, NAT is your bottleneck. Yeah. When I say scale up means you increase your network capacity in the private side. So because the number of devices wanting to go into the internet, that means your NAT will be overwhelmed. So now you have to provide multiple servers with NAT. So I'm thinking about the ISP part, yeah. So there are issues with NAT. It's not very scalable. Now, the last one, Internet of Things, we already start to see smart watches, smart lights, smart lock, smart everything. Just put the keyword smart in front to basically say that particular thing or object is online. Okay, that means you can access it through online. It can send its data from it for whatever sensor it has to the cloud. So in order to do that, it needs internet. Okay, to the cloud, and then the cloud will process it, and then consume normally in their app, on their smartphone, on the computer, right? They are also talking about edge computing, whereby they make this Internet of Things smart at the edge point of view instead of the cloud. But it's a mixture. We have edge computing and also cloud computing. So some IoT will rely on cloud computing. Some IoT will do their own processing at the edge. So we call it edge computing. But whatever it is, this Internet of Things will be connected to the internet. So each of us might be having, each person or each household might have a lot of Internet of Things that is connected. Nowadays, you go to Lazada, you can buy all these smart smart stuff, and it's now have gone down in price as well, so it's affordable. When you have a smart TV, your TV is connected online. Okay, you have your Bluetooth player, but your Bluetooth player also is able to connect to Spotify maybe, or to Tidal. Okay, these are Internet of Things. Okay, anytime when an appliance that used to be offline is connected to the internet, then it's part of the Internet of Things, and this again bring with it the extra burden of needing the IP addresses. Again, if we hide the fact that it's using private addresses, we place burden on the net server. All right. So all these problems, okay, actually is accumulating. It's growing more and more. Okay, that's why we hope that IPv6, the embrace of IPv6 is going to bring us some relief from these problems. Okay, but in the meantime, during the transition period, IPv4, IPv6 coexist together. Okay, because even though at your site, for example, whether it's local or remote, your own organization maybe is fully IPv6. You're very forward thinking, and you have the budget to implement. But when you start to go online on the internet and you're accessing other people's server through other people's network, then you have no control whether it's all fully IPv6 or IPv4 still, or maybe it's a mixture. And that is why we have this IPv4 and IPv6 to coexist. That means they are run at the same time. Okay, so we have 3 migration techniques that is being employed. Right. So the first one we are looking at is dual stack. This simply means that IPv4 and IPv6 protocol coexist on the same network. So you'll see that if you try to eavesdrop on the network, when you look at it, you'll see some packets are IPv4, some packets are IPv6. Right? So the devices connected within this network all are able to process both IPv6 and IPv4. Okay? Because it's a mixture, because not all of your devices fully transition to IPv6, right? That means here, if you want to understand it, means if this is IPv6, okay, and this is IPv4. When this one is IPv6 as well. So when this communicate with this, maybe they will use IPv6. But when this computer wants to communicate with this computer is IPv4, then the IPv4 stack is used. So that means if I want to use IPv4, I use IPv4. I send through IPv4. If I want to use IPv6, I send using IPv6. Example, to work together, but they are separate, but they work concurrently together. So the second technique is tunneling. Let's say your branch, or maybe your own branches, but maybe your even with your business partner or competitor, whatever. Let's say the two parties support IPv6, but you have to go through this internet or ISP where it's an IPv4 only network. It wouldn't work here. So instead, we use tunneling. So that means your IPv4 packet, let's say this is IPv4 packet, is encapsulated by an IPv6 packet. So it's IPv6 encapsulated by IPv4. Inside the data is IPv6 packet, but outside for the purpose of forwarding through the network C that is IP version 4. When you reach your IP version 6 only network, then this IP version 4 network encapsulation is removed and the network will see IP version 6. Okay, so originally it's IP version 6. Okay, encapsulated while traveling in the network as this is version 4. So we call this technique tunneling. Sorry, 6 here, 4 here. 4 encapsulate version 6. Okay. Right. The third one is we make use of a translator. So we call this translation. Okay. So we'll use the a version of the NAT earlier on. Earlier on, we think about NAT as, simply translating between private address and public address. Okay. With the NAT 64, a version of the network address translation, NAT 64 is converting it because inside the packet is data. Actually, we just want to transport data. So encapsulated using version 6. When you reach the NAT 64 router, the encapsulation is changed to version 4 so that it can be recognized inside IP version 4 only network. Right? So which device translate between IP version 6 headers to IP version 4 headers? NAT 64 router. So it goes both ways. So coming in is version 6, coming out is version 4. So going out version 4 from this network, coming in will be version 6, translated by this NAT 64 router. Okay, right. So these are the 3 migration techniques. That means it's temporary. Eventually, we want all to be IP version 6. There's no need to do tunneling, dual stack, or translation. But in the meantime, okay, where we still have a mixture of IP version 6, IP version 4, so we use these 3 different techniques. Okay, so which one you want to use is based on your needs, your organization needs. Which one is easier for you to implement? Which one is cheaper for you to implement? Yeah, based on your company.
Thanks for tuning in.
The easiest is this one. This is what we are using by default. Okay, by default we are using this because if you look at your network, okay. If you look at your network, let me just change adapter. Oops, yeah, I'm using Wi-Fi. So if you look at here, look at properties. I can see I have this protocol version 4, and also have this protocol version 6. So my computer, my device is working on dual stack, running both. So this is most popular for most end devices. Okay. Right. Let's look at the format for IP version 6. Right. So we know that IP version 6 is there's more bits so that we can have more address. Okay. So it's 128 bits. If you divide by 8, means we have 16 bytes. With each byte means 8 bit. So 128 divided by 8 is 16, so 16 bytes, right? Because we want to represent no longer using decimal numbers, we want to use hexadecimal numbers, hexadecimal digits. So we can take 4 bits and represent it by 1 hexadecimal digit. We call that 1 hex digit can be represented by 4 bits. Okay, the maximum value for hex digit is 15. That is four bits or all ones. Okay, example like this. That's F. Sorry, that's F. That's F. F. F meaning 15 in decimal. If you convert, you can see that it's 1 plus 2 plus 4 plus 8. Okay, that gives us 15. So 15 in hex is F. Thereby, F is the maximum digit in hex. Thereby, we can represent hex digit with 4 bits. So if we represent hex digit with 4 bits, we have 16 bytes, means each byte is 8 bit, means we have double of that. So we have 32 hex digit. Okay, and we separate the hex digit using colon, right? So instead of calling it octets, because in IPv4 we call it octet because each grouping of bits is 8 bits. Okay, here each grouping is 4 bits. We call it hextet. Okay, sorry, not 6. 4 hex digit grouping of 4 hex digits. So we call it hextet. Right. Right. Okay. So examples of IPv6 address. Okay. All right. So, but you look at this, each of this is an address. Okay. Every row is an address, and look at how long it can be. Right. So we come up with a way to reduce number of digits, but we still maintain the information. Think about lossless compression. We want to compress, make it smaller, but we don't want to lose any information. We still want the full address. We call that lossless compression. Contrast with lossy compression. Lossy compression means you compress and you lose some information. We just hope that those information you lose is not so important. And we find this mostly in image files, and video files, and audio files. Lossy compression. But for IP address, we want the whole digits, but we still want to compress. So we want to use lossless, means there's no information loss, but we are able to compress. Okay, so to compress it, we simply follow 2 rules. Okay, and I want to say right now is this question is very popular, so make sure you know how to compress an IPv6 address. Okay, so the first rule is shown here. First rule is to omit leading zeros in any hex tag. So you only omit or remove leading zeros. Trailing zeros cannot remove. Okay, meaning means leading zeros means in front of the digit. Trailing means at the back. At the back or trailing, you don't remove. Yeah. So examples for this group of four hex digit or hex tag, we remove this one, leading, right? For the second one, we remove this one. The trailing one cannot remove. So for the third example, remove the leading ones. Okay, leading zeros, and so forth. The fourth example, only the leading zeros will be omitted. This is your first rule. Okay, so we are done with the first rule, but we are not finished yet. Okay, that we go to the second rule, but let's do another example. You're given an address. Okay, go hextet by hextet, removing the leading zeros. It's highlighted here in orange color. I think it's orange, not yellow, right? Orange. So rewrite it without the leading zeros. Second example, third examples. Okay. If you have hextet with all zeros, don't remove all zeros yet. Remove leading zeros, leave 1 0 behind as such. Right? This. If you are in a hexstat, all zeros, remove only the leading 3 zeros and remain 1 0 at least. Okay. Rule number 2, because there are 2 rules, only 2 rules. Do the first rule first, and then when you're done, do the second rule. Okay. So the second rule is look for 0 segments. 0 segments mean, remember we remove leading zeros and we leave 1 0. This, when we only have 1 0 after the rule 1, means these are the 0 segment, okay, indicated in green. Okay, you would want to, if you have 2 options, equal, here you got 2, here you got 2. It must be contiguous together, cannot have any number in between. So when we see something like this, we can just remove the 0, okay, omit these 2 0 and the intervening colon and come up with something like this.
We cannot use two of the double column. We cannot use both at the same time.
What do you mean? For this
yeah,
and this,
yeah,
and
both,
this.
yeah, both at the
Yeah,
same
because
time.
it will be ambiguous. After we compress, if we compress both, okay, so that means here also double column. Then later we want to uncompress, we don't have enough information because it could be it's 0, 0, 0, 0. It could be 0, 0, 0, 0. It could be 0, 0, 0, 0. So if you eliminate both, it can lead to confusion, ambiguity. So we don't do that. We want to be able to reveal back the full address. Okay, if we eliminate this, then what we end up is something like this one also dot only, right? Then we don't know, is this 1 0, 2 0, or 2 0, there's confusion. So we just take one, compress that part and leave the other one. This one only if they are equal. That means 2 zeros here, 2 zeros here, choose one. And if you have imbalance, 1 0 here, 3 0 here, you always pick the larger one to compress. Okay?
The larger one is the 3 0 one.
3 0. Okay? But when there's 2 0 like this, any one you choose is okay. You choose the first one to compress, fine. You choose the second one to compress, fine, but not together at the same time. Okay? Right. Let's have a look at the examples. So here, we eliminate rule 1, eliminate leading zeros. This one is easy, no need to choose. You can see straight away there's a contiguous zeros here. Okay, so remove all, become compressed like that. So this is shorter to write compared to this. Now remember, this compression is for the benefit of human beings. Okay, human beings. Computer don't care. Computer prefer. Computer doesn't really matter whether you compress or not. But for humans, this is easier to write compared to that. Okay, it's very long, and especially when it's just repeating, right? Okay. So how do we decompress? Because if we say that it's lossy compression, lossless compression, we should be able to reverse the process. Well, you have to know your information here. 16 octets. sorry, not 16 octet. This is 16. It's 1, 2, 3, 4, 5, 6, 7, 8 octets, right? Sorry, hextet. 8 hextet. So you need to know that it's 8 hextet. So if you want to reverse the process because you want to get you want to get back, right? So here we have 1 octet, 2 octet. So we still have 1, 2, 3, 4, 5, 6 put back in, right? So you just reverse the process. Go to this, then go to this. Then you get back the full address. Okay. Right. Let's look at the second. These are highly unlikely. This one is very likely because we know some of the linked local address like that. But this, yes, there's an address something like this, but it's not common. But you can. Okay. Eliminate all. You're left with this. Yeah. And it's very easy for us to decompress. If we have this, we go back here. We just put back all the zeros. From here, you put back all the leading zeros. You get back the original address. Okay. So in summary, first rule, eliminate all leading zeros. Second rule, find the largest contiguous zeros. Okay, and remove it. Right? Or yeah, sorry. Question?
This IP where all this 0, is there anybody use?
I think this is a special address. It's not used for. It's a special address. Later we'll see when we look at the types of address.
Okay.
Right. Okay. So when there are two parts or more where you have equal number of zeros, then you simply choose one of it to compress for rule 2. Okay. You cannot do both, but you have to choose one and compress that part. Okay, this is when there are equal number of contiguous zeros. Okay, in areas of the IPv6 address. Right. So let's go to this section. This section tells us the different address types. Just like IPv4, you have different address types. IPv6 as well. Okay, but I think that it has slightly more, right? So with IPv4, IPv6 also have 3 unicast, multicast, and anycast. We don't call it broadcast anymore, right? Yeah, but if it is actually work very similar to broadcast. Okay, just that we don't call it broadcast because IPv6 is meant to be end-to-end address, exactly what was envisioned for IPv4, but because IPv4 ran out of address, so we have that kind of router NAT there to you don't have no longer have end-to-end addressing. Okay, it will be translated by the router. Okay, using NAT. So coming back to IPv6, we now have the opportunity to have end-to-end. You don't need NAT, no problem. Okay, so it doesn't make sense to have broadcast, the name broadcast anymore, right? So IPv6 does not have broadcast address, whereby you have FFFFF, right? For the data link, and also you have the 255 at the back, right? So at the host address. So this, but we still maybe need to send a message to all the devices within a link, right? So we have this Unicast address, right? Okay, right. So let's look at IPv6 prefix length. We introduced prefix length to indicate subnet mask, right? So in IPv6, we use the prefix the same way to indicate the network portion. How many bits belong to the network portion? So the prefix length can range from 0 to 128, of course, because that's the length of the bits. Okay, whether you want to use from 0 to 128, it depends. But in most cases, of course not, because if you take up the entire space of 128 for network, then you don't have any host left. Okay, the most general one that we will be using in local area network is /64. That means you divide into two. Okay, 64 bits for network, then 64 bits left for the host. Okay, in this case, we call it the interface ID. Okay, right? So note, it says it's strongly recommended to use 64-bit interface ID for most networks. This is because stateless address auto configuration slack. This slack is innovation from IPv6. Okay, it is a different protocol compared to DHCP, but Slack can be used for as a service to replace DHCP. Remember DHCP? DHCP is dynamic host configuration protocol, where we can get the IP address in version 4. We can get the IP address from the DHCP server, so we don't need to manually configure it. So in IPv6, there's a protocol called Slack here, stateless address auto configuration, which is added. You can use it together with DHCP version 6, or you can use it on its own. That means you don't need to have a DHCP version 6 protocol on it. Okay, so it says that if your network, if you want to create a network and you are recommended to have 64-bit for interface ID. So if here is 64, that means prefix 64, because we divide, right? Because Slack uses 64 bits for the interface ID, which means if you're using Slack to auto-configure your IP address versions, IP version 6, Slack will generate or provide you interface ID, which is 64 bits. Okay. So means in most LANs, you probably will find prefix, which is 64. Okay, due to the fact that it's easier if you then decide to use Slack, then it match with what Slack is using, right? All right, so unicast address, multicast, anycast. Okay, so now we focus on the unicast, the one-to-one address. So the one-to-one address, similar to IPv4, IPv6 also have several different types of unicast address. Okay, so here let's very briefly look at the right-hand side. You can see IPv6 unicast addresses. There are global unicast, link local, loopback, unspecified, unique local, and embedded IPv4. Right. Now let's look at global unicast. So the GUA or global unicast address is basically the same as the public IPv4 address. This global unicast address is the one that is internet routable. That means if the router sees this address as destination address, it will route it to forward it, because it is a globally unique address, the ones that can be used on the internet. Okay. Now, before I proceed, let me mention something first. Even though IPv6, the network, the address range is so big, and it gives us the opportunity to do end-to-end, no longer needing NAT. Okay. Right. Okay. But certain organization, okay, probably still want private network. Okay. They still want to translate because they want to hide their internal networks from the internet. So that means most probably due to administrative or mainly security reason, okay, you won't see, even with IPv6, a end-to-end addressing, which means even though we are capable of assigning global unicast to every host, even inside your own private network, but probably you won't, okay? Depending on the policy of that company. Because like I said before, they want to hide, they want to hide their network from prying eyes of the internet. So they want to probably design their network very similar to how it was before transitioning to IPv6 due to admin or maybe security, but mostly because of security, I think. Right? So let's look at the second link local address. So link here means a LAN, okay, in the same network. So link local address means address that needs to be there for hosts within the same network to be able to talk to each other. All right? Okay, so you can think of it maybe very similar to private address. Okay, now each host can actually have global unicast and link local. If you want your host to not be able to communicate on the internet, don't give this. At the very least, to make it useful, your host, you give it link local address. The link local address is needed for the host to communicate among itself inside its own network, but it is not routable. Okay, you need this to communicate beyond your own network to go to the internet, to talk with computers on the internet. Okay, so without this, you cannot talk remotely. Okay, but at the very least, you must provide link local address, or else your computer cannot communicate with another computer within your own network. Okay, within your own LAN. Confined to a single link means within your own local area network. Okay, right. So IPv6 global unicast addresses are globally unique and routable on the IPv6 internet. Currently, that means presently, right now, only GUAs with the first 3 bits of 001 or GUAs with 2000/3 are being assigned. So /3 means the first 3 bits, right? Because that's the network portion. Okay, only that is being assigned because this is they not sure whether the same authority for IPv4 is in charge of IPv6. Should be that, right? Because there's no need to duplicate the admin part. Okay, so for now they are providing the global IPv6 address. So at the moment, only the one with 0001 is being assigned. So available GUAs begin with decimal 2 or 3. This is only 1/8 of the total available IPv6 address space. So basically, because the numbers are so big, numbers are so big, we even with only the 3 bits, this represent 1/8 only of the total IPv6 address space. Okay, so you can imagine we still have 7, 8 unassigned, right? I think as more and more devices are transitioning and more devices added to the internet, then we'll start to see more and more bits being signed up, right? Okay, global routing prefix. Let's go back here. You can see that global routing prefix here. Okay, is the prefix or network portion of the address that is assigned by providers such as ISP to a customer or a site, right? A site means you have a larger, your bigger customer, your networks now is considered a site. That means you basically have a large network or networks. Okay, the global routing prefix will vary depending on ISP policies. The subnet ID, okay, field is the area between the global routing and the interface ID. Subnet ID is used by the organization to identify subnets within its site. So ISP, because it has a lot of companies, that will subscribe to it. So it will determine this part. ISP will determine this part, the global routing prefix. So if this is already assigned, then this part. Okay, so the ISP will generate this part and select what the global routing prefix to give what customer it has. Once the customer receives it, the customer can use this part to create its own subnetworks. Maybe because, as we say, site, more than one LAN, more than one network, then you need a way to differentiate between the network. They cannot touch this part. This part is already pre-allocated by the ISP. So the organization, the customer, will make use of this subnet ID part. Okay, as you can see, this part is for identifying hosts within the subnet. This to identify which subnets, okay, which subnets of that organization. This part is identified by the ISP, which customer, which of its customer is given that global routing prefix. Okay, so the company only have control over subnet ID, or the customer only have control over this. Okay, so you can see subnet ID is used by an organization to identify subnets within its site. And then the interface ID is basically the host address part. Okay, so again, it says strongly recommended in most cases /64 subnet should be used, which creates 64-bit interface ID. So here must be 64. Okay, so this together will form 64 bits. This 64 bits, right? Note, IPv6 allow the all zeros or all ones host address to be assigned to a device. The all zeros address is reserved as subnet router Unicast address. Remember Unicast? This is a replacement for broadcast. So it's called subnet router Unicast address. And this one should be assigned only to routers, the one with the all zeros address. Okay. Do you remember asking me? I think it was, is it Kelvin or Noel just now? All zeros address?
Oh, yeah.
Right. Yeah. Structure of an IPv6 GUA, right? Currently, only global Unicast address with the first 3 bits of 001 is being assigned. So Of course, you can go and try to use, but then the ISP won't recognize the address lah. Okay, if you say, oh, I want to create my own 0001, but unfortunately, the routers belonging to the ISP will only recognize something with 001, and you find that your address will not be routed. If you're thinking about, oh, why not we just, yeah, okay, it's already assigned to you, isn't it? The global prefix. Right, so a global Unicast address has three parts: global routing, subnet ID, interface ID. Just now we talk about it. This is the format and some example of how they will use it. Okay, right. So if subnet ID is given as 4 bits, sorry, four hex, one hex tab basically. One hex tab is 4, 4, 4, 4 is 16 bits, right? If one hex digit is 4 bit, so 4 by 4 is 16. So subnet ID 16 bits means, let me just give you an idea. So 2 power 16. That means as an organization, you can create about 65,535 networks, your own networks. Okay. Yeah. That's I think quite sufficient for most organization. Right. So here we are talking about link local address already. We left UA and then go to link local address. So link local address is needed to enable the device to communicate with other device which is on the same link and only on that link. Subnet means LAN. All right. Okay. So packets with source or destination LLA cannot be routed. That means it will not go beyond your router. Means only inside your LAN, right? Okay. So every IPv6 enabled network interface must have this LLA. Okay. Because the minimum that you can do is communicate with other hosts inside your own LAN. So the minimum you must have must be the LLA address. Okay. If you don't manually configure, very similar to when we talk about the IPv4, whereby your OS will there's a range that the OS can basically take and provide to your interface. So in IPv6 protocol, if you did not set the LLA, that means manually, then your device, that means your OS will also create one for you. Okay, so IPv6 link local addresses are in this FE8000/10 range. Okay. Right. So this diagram basically shows that hosts use LLA of a local router as the default gateway. So this remember we set the FE in one of our practical as the gateway address that belongs to the router. Okay. If you want to send out, you send to the local router, and the local router will then translate if it's allowed if your router is configured to forward, or else you will be talking within your own network only. Okay, now let me just make this thing clear. This is one network. This is another network. Okay, so there is a LLA addresses within this network. There will be also a set of different LLA addresses within this network. So here, these two, you see, these two interface belong to the same link, same network. So these two can communicate. Whether it's forwarded or not, then decision is based on the router. Okay, and this also using it's in the same network. They can communicate, but whether it's forwarded or not, again based on the router's routing decision. Okay, the concept of routers separating networks. Okay, here of course we don't, to make it simpler, we don't put the switch here, right? But of course in a real network you have a switch. But the switch, it doesn't really matter with IPv6 because switch work with data links or switch doesn't, not even aware whether it's IPv6 or IPv4. Okay. Right. A note about unique local address. Now, unique local address is something else already. Yeah. Okay. Just now was local link address, and then now we are talking about unique local address. Okay. So unique local address, or EULA, range from this value to this value, right? So it has some similarity to RFC private addresses. This is the request for comments document number. You can actually track this down online, because request for comments, because remember this is open standard, so there will always be shared publicly, request for comments. So just type this number, you can read further, right? So very similar to the IPv4 private addresses, but there are significant difference. So unique local addresses are used for local addressing within one site or between a limited number of sites. So that means it can go beyond a link, just within a site or between a limited number of sites. Unique local addresses can be used for devices that will never need to access another network. Again, you can limit it so that it talks within the same network only. That means you can see they never need to access another network. It means it doesn't, you can set it so that only local area network, it doesn't go beyond the router. Okay, but one thing is not globally routed, means it will never go outside of your network or networks. It will not cross over to the internet. Internet capable routers will not route it. Okay, so routers are, you have to, even though it connects network, the way it's configured, it depends on what it's meant to use for. Inside your own organization, the routers might be transferring or forwarding packets between your own networks. Okay, but then there will always be the edge router that connects to the internet. Okay, so when I say internet capable routers that basically routing packets on the internet, okay, able to access or forward, able to access the internet, also forward packets to the internet or receive packets from the internet. These are the internet capable routers. Usually, it belongs to ISPs. Okay, ISP operates this kind of routers. That means your own organization will never have this kind of routers. You know what I'm saying? The business, the consumers part. Okay, business consumer or normal consumer of an ISP will never operate routers that is directly linked to the internet. They have to go through the ISP's network, and the ISPs are the one that operates routers that connects directly to the internet. And normally, when they connect to the internet, they connect to the high speed network. Yeah. Okay. Many sites use the private nature of request for comment 1918 addresses to attempt to secure or hide their network from potential security risks. Remember, this was never the intended use of unique local addresses, right? Because this is not routable. So this, they use this addresses if they don't want any outside networks to be able to access it, right? They are like the private addresses. Right. Okay, we move now to the loopback. Similar to the IPv4, we have loopback address. This is used mainly for internal to the host. The host wants to communicate between one or more processes within its own host only. So processes inside the host want to communicate via network to each other, but they are in the same, these processes are in the same computer, in the same host, right? So if they want to communicate in that way, they have to use the loopback address, very similar to 127.0.0.1 for IPv4. For IPv6, this loopback address, all zeros except the last bit. Okay, so normally we represent as :1/128 or just :1, and this is loopback. It will point back to yourself if you use this address. Okay, so this is the unspecified address that was asked. All zeros address simply : cannot be assigned to an interface and is only used as a source address. This unspecified address is used as a source address when the device does not yet have a permanent IPv6 address, or when the source of the packet is irrelevant to the destination. The destination is simply receiving the packet without wanting to reply. Okay, and the only reason why you don't care about the source address is because you don't need to reply. Okay, right? So the last one is IPv4 embedded. Okay, this is used to help transition from IPv4 to IPv6. Right? So this is used as part of the migration technique we talked about earlier on. Embedded means embedded within IPv6, right? Or IPv6 embedded within IPv4, whichever you want to use, you can invert it, right? Right. Dynamic configuration of IPv6 address, global unique address. All right, so how do you configure? This is basically the packet tracer part, right? You're given the address and you configure. We have already done this in last week's practical. These are the commands. Okay, go into the router, config terminal. Will allow you to go into the configuration terminal and then specify the interface that you want to configure by typing interface and the interface name and number. Once inside, you can see that's the config interface. Okay, config interface and the router. Type IPv6 address and the address that you want to specify. Don't forget, type no shutdown to bring up the interface. Exit will bring you one level up back. Okay, go back to config and continue to configure the rest of the interfaces. Okay, still remember, yeah? Last week we did this one, right? Okay, that is for the router. Here we do for our Windows host. Okay, very similar. We can specify the IPv6 address, subnet prefix length, and the default gateway. Okay, when here a special note here, you can either have Dhcp version 6. Okay, this is the version 6 of the Dhcp protocol we mentioned when we talk about IPv4, or the newer one, okay, the Slack. Okay, so when any of this is used, the link local address of the router will be automatically specified as the default gateway address. Okay. Yeah. Question?
No.
That means this one is the LLA is already configured inside your router. Okay, so when it's detected, when you're using this one, obtain automatically instead of manually. Okay, the link local address will get it from the router. Okay, you know what I mean? This one automatically will get the LLA that you configure on the router. That means you don't have to configure it yourself, right? RS and RA messages. So RS stands for router solicitation. RA stands for router advertisement. Okay, so devices can obtain the global unique addresses dynamically through the ICMP version 6 messages. This is different from the ICMP version 4. Okay, so this is the extra feature provided for the new version 6 ICMP protocol. Yeah. Okay. Router solicitation message are sent by host devices to discover IP version 6 routers. Okay, it means host devices, not routers. Host devices send out RS messages. He wants to know, are there any IP version 6 routers within this network? Then the reply, the RA, are sent by routers to inform hosts how to obtain an IP version 6 global unique address and provide useful network other information, such as network prefix to be used, okay, and prefix length, default gateway address, DNS addresses and domain name. So now you can see that the router for IP version 6 can provide this, okay, rather than DHCP. Okay, so inside the RA messages, it can provide 3 methods depending on your network, how your network configuration. Okay, three methods to configure the automatic part. When you set that, instead of using static, what happens is your host will send out RS. Okay, because in the host you said obtain automatically. So your host IP version 6 host send out RS messages. Okay, if there are any IP version 6 routers, they will send reply with RA messages containing network prefix length, default gateway address, DNS addresses, and domain name. Okay, we know this one, right? Domain name service. It performs the resolution of domain name to IP address. Okay, instead of typing the IP address, you type Cisco, right? Cisco needs to be resolved. What is the IP address for Cisco? So DNS service will provide that. So RA will send you the DNS addresses and domain name. RA can provide 3 methods to configure the IP version 6. It will inform the host whether by Slack, which stands for stateless address auto configuration, or work together with DHCP version 6 server. Slack with stateless DHCP version 6 server. Stateless here means the DHCP version 6 server has no information about the host. It just provide some information that it can be used by the host, but the DHCP version 6 server will not keep track. Right? So that means only partial information is given by that server, the DHCP version 6. Other information will be given by Slack. So first is everything will be provided by Slack. Second is some will be provided by Slack, some by DHCP version 6 server. Okay. And the third method is stateful DHCP version 6, which operates very similar to the DHCP version 4 server, where everything is provided by DHCP version 6. Okay. In that case, there's no Slack. Okay. So why no Slack? Maybe your router is not that capable. Okay, your router may not have this service, or you didn't enable this service in your router. So then, but you do provide DHCP version 6, so this DHCP version 6 will act in stateful manner, meaning it keeps track. If it gives you the IP address, or it gives you, it gives that particular info to you. So it keeps it keeps the state, it keeps information. Number two is stateless. That means it can only give you some information that it doesn't need to keep track. The rest will be given by Slack. Okay. Right. Slack allows a device to configure a GUA without the services of DHCP. That means the first option. Devices also obtain necessary information to configure a GUA from the ICMP version 6 RA messages. Remember, RA is from the router to host. The prefix is provided by the RA, and the device used either to create this interface ID. To create the full address, you need both prefix and interface ID. Prefix is given by the router router addresses. Is it router addresses? The RA messages, and then the host will either use the two algorithms. One is EUI64. Okay, Windows used to use this, I think several version back, but now Windows use random. Okay, so either use EUI64 or random generator software, random number generator to create the interface ID. Okay. So basically, if you use EUI, basically it will make use of your MAC address. If you use random, it doesn't make use of it. So sometimes you prefer to use random because you don't want to be tracked. Since this is GUA, global, right? So global means it can be used on the internet. So if you use EUI64, one of the, I think that this same issue happens with smartphone. Okay, if you use your MAC address, you can be targeted, not targeted. How to say this? Can be tracked. It's like a it's like a stamp. Yeah, meaning to say, oh, this message definitely comes from your machine because your machine have that how do you say this? MAC address. Okay, EUI make use of the MAC address. So if you don't want to have this kind of, some people can say that okay, never mind, but some people see this as an invasion of privacy or security issue. So the second way, random number generation, is a way to create a unique interface ID, yet doesn't reveal your machine, for example. Okay, and of course we don't have any control on this. This is done by the OS. I think Windows 10 is now using random generation. I think previous version of Windows uses the EUI64 method, right? So the RA can instruct a device to use both Slack and Stack. This is the second method. Okay, the RA message suggests device to use the following: Slack to create its own IPv6 GUA. The router LLA becomes the default gateway address for that host. A stateless DHCP version 6 to provide DNS server address and domain name. Since DNS server address and domain name do not need to be tracked, that's why DHCP version 6 can be stateless. Okay, right? So half information from Slack, half information from DHCP version 6. Right? This is the third method. Stateful DHCP version 6, there's no Slack. That means you either disable it in your router or your router doesn't have this feature. So the router can tell, okay, use DHCP version 6. Right? Stateful DHCP version 6 is the traditional way a DHCP server works in IP version 4. Right? So the everything that's in 1 Slack provide, now in 3 DHCP provides. Okay, right? All right, so now we look at the EUI64 process versus randomly generated. Remember I said that EUI64 make use of MAC address. Okay, so you can see let me just go here. The IEEE defined the extended unique identifier or modified EUI64 process, which performs a 16-bit value of FFFE in hex is inserted into the middle of your 48-bit Ethernet MAC address. That's why I said if you use this method, when you extract the IPv6 GUA, you can actually, well, you know the format, so you can extract the MAC address. Okay, and you can reverse the process. You can tell the MAC address of the particular computer. Okay, this works because we know that the MAC address is globally unique. Every MAC address is burned onto your NIC is actually unique globally. You guys recall that? So this EUI process make use of that. Just insert additional 4 hex digit in the middle, and the 7-bit of the MAC address is reversed from 0 to 1. Made to 1. Okay. So again, it's a concern. Not everybody have this concern, but it's a concern, right? That particular machine can be identified. Right, so this is the process, EUI64. This is to create the interface ID. Okay, the interface ID must be unique. This is one way to create that uniqueness by using information from your NIC MAC address. Okay. All right. Type IP address, sorry, IP config. Inside your computer, you will see the IPv6 address. So you can see the first 4 hex stack belongs is given from the RA, from the Slack, from the RA message, and then the last for the interface ID 64-bit number is randomly generated. So current version of Windows use randomly generated interface ID, right? So I'm not sure what is this random function they use. Okay, there are many random functions, and if you start to use the Java programming language or any other languages, you probably have library to generate random numbers, right? So random numbers can be random, but it's usually on computer is pseudo-random, right? And different algorithms to generate random numbers. There are certain better ones, some not so good, right? Okay. There are many libraries lah, basically, but this one you have no control over. But you as a programmer, you will start to, if you are how to say this, if you have any need to create random numbers for very simple purpose, random number generator is sufficient, the normal one. For generating a very unique idea or UID, then depending on what you want to use it for, because there's some collision depending on the algorithm and also repeatability. If you want truly random, you cannot depend on computer, basically. I think if you read further on random number generator, you will find some very interesting information about it. Okay. Well, okay. So there are many more, but I don't talk about it in this subject. If you want to know more, you can read more about random number generator. Right? But I think Windows Vista, starting from Windows Vista, they start to convert to random generator for Windows or for Microsoft. I'm not sure about Linux. Okay, you guys can find out. Okay, if Linux use what? Is it random or still EUI 64? Right, but both have what I mean to say. Both have their own ways to generate. Whether you use EUI or random, their purpose is to create the unique number. Okay, right. Dynamic link local addresses. That means link local addresses that you can get dynamically. Okay, link local can be set dynamically. That means you ask Dhcp or Slack, or you can configure them manually. That means you type in yourself, right? Cisco iOS routers use EUI64 to generate interface ID for all link local address on IPv6 interfaces. Remember, each interface on a router has its own MAC address. So it's possible for the iOS to actually extract the MAC address from the interface, using EUI64 process to generate interface ID for link local address. Okay. Drawback to using dynamically assigned link local address is the long interface ID. Why? Because, of course, because you are using the MAC address, the EUI64. If you leave iOS to do it for you, then it will use EUI64 process, which means the MAC address is using MAC address, so it's going to be long address. Okay, so if you don't want that, you can actually put in the address yourself. Okay, so if you put in the address yourself, you can have a shorter interface address by compression, remember, and then put 000 inside. Well, of course, it will not be as random, but since it's a link local is only available in the link in the same link, it doesn't cross over to the internet, then it's fine, as long as it's unique inside your own network. Okay. So if you can control that, then you might want to configure statically or manually. All right. So manual configuration of the link local address allows the creation of a simple, easy to remember address. So basically, you replace with zeros. Then, as long as the end part for each interface you can change if you want to change, right? But link local allows you to communicate within your own link and inside your own network or networks only. So you can have the interface to have to be the same, right? That means all the hosts will take the router link local address as the gateway address. Right, verifying IPv6 address configuration. We did this earlier on. We can do similar commands in the router, show IP version 6, yeah? Instead of show IP version 6 interface brief. It shows you very brief information about your interface, mainly the addresses you have configured. If you want to see the routing table for the router, you type show IPv6 route. Okay, this one you will learn a little bit more in the next course, but here you can see that there's connected, local, static, and per user static, right? So basically, it's basically indicating whether the router, if it's directly connected, the router knows the address, the network address that the interface is linked to, because the router knows all the directly connected networks to it via which interface. So you can see connected, right? But it also is able to learn about routes based on exchanging information with other routers. So these entries could be it knows by itself, directly connected, configured by getting information from other routers, or statically manually entered by administrator, right? So the routing table works is that the router opens up the network layer header, look at the destination address using the ending to extract subnet for IPv4. Here, the subnet mask is already given by the prefix, right? Okay, and perform a very similar operation. Then compare the network address. Which one match? It will say, oh, okay, forward via that interface. Okay, so when you see receive there, receive is received from other routers. Directly connected, it knows because it's directly connected to that particular router. So if you want to see the routing inside the routing table, okay, see whether your configuration correct. See if you cannot route. You see everything else is working fine, but still cannot route. Maybe your routing table got problem. So you show IPv6 route, and it shows you the routing table. Okay, and then of course the ping in the router works well both with IPv4 and IPv6, able to differentiate between address. So you don't have to say a different command to ping IPv4 address or to ping IPv6 address. You can use the same command. Okay, so inside routers you can then ping from there. Okay, this is to detect any connection via any of its interface, any problem or not. Okay. Basically, the process of verification is to slowly target which part of your network is not working, because you might have your network may have different LANs connected by routers, and then you want to ping from one end to another end, and it says error, cannot ping. So you want to narrow down into which segment of the network got problem. So you try to ping interface of the router. You can go to the router, ping from router to the host. So then you can segment by segment, you can pinpoint, okay, from this part it's able to ping. This part cannot ping, so you know already. You focus on the part where the segment that has problem. Okay, so it allows you to hone into the problems, so then you can fix. Okay, so troubleshooting is very good to use this command. All right. Okay. Randomly generated interface ID, depending on the OS again. Oh yeah, Windows Vista, right? Beginning with Windows Vista, use random. Before that, it was EUI 64. Okay, so to ensure, because they have collision means we generate, even using random process, you can generate the same number. As I said before, the only way to make sure is to use, well, the true random number generator, every random number generator has a seed. Okay, a pseudo random number generator like Windows, if you give the same seed, it will generate you the same random number. So the key is to make sure the seed is random if you want really random numbers. after one number, there's no collision. But the only true way is to physically attach as a sensor. Maybe you can use as the barometer or temperature or whatever, something that is in nature that's truly random as the seed to your random number generator. Then you can really get a random number without any collision. But of course, we can't do that just to generate the address. So they might employ a way to detect duplicate address. It means the random so-called random number generator actually generates similar random number. Okay, so in that case, if that happens, at least we have this process called duplicate address detection to detect. Right? It's similar to an ARP request for its own address. If there's no reply, then the address is unique. Okay, we'll broadcast it. Any one of you have this number? No. You reply back? No. Then, sorry, there's no reply lah. If there's a reply, yes, this actually belongs to me, then you know there's a collision, so you don't use that address. You generate another one. There's no reply after a period of time, then the address is unique, then you can use it. Right? Dynamic addressing for IPv6. All IPv6 interface must have IPv6 link local address. Like GUA, LLS can be configured dynamically. That means can get from Slack or Dhcp. The figure shows LLA is dynamically created using FE80/10 prefix and the interface ID using EUI64 process or randomly generated 64-bit number. Okay. Operating systems such as Windows will typically use the same method for both a Slack created GUA and a dynamically assigned LLA. Okay, so you can see either one lah. You can do. You can randomly generate it, or you can EUI64 it. Right? Cisco routers automatically create an IPv6 LLA whenever a GUA is assigned to the interface. By default, Cisco iOS routers use EUI64 to generate interface ID for all link local addresses on IPv6 interface. So it's using EUI64 processor, okay, making use of the MAC address. Okay, so this is an example. Okay, when you see FFFE, you know it's using EUI64. When you don't see that, it means it's using random. But of course, in Cisco routers, it's using EUI. Okay, but in your own, so if you want to see for Linux, for example, check the LLA for Linux. If you see FFFE, then you know, you confirm that it's EUI64. If not, then you know it's random, very similar to Windows. You can check Windows one as well. Right? Okay, here's an example of LLA dynamically configured on the gigabit interface of R1. Okay. IPv6 multicast addresses. So this now was Unicast and all the different Unicast address and how generated dynamically or manually, yeah, and the configuration commands you can use at the router. Okay, now we move on to multicast addresses. IPv6 multicast address have prefix FF00, prefix /F. There are two types of IPv6 multicast addresses: well-known multicast addresses and solicited node multicast addresses. So well-known is fixed. I mean, it's well-known, so it's fixed. It's not going to be. People already know. It means hosts already know that this kind of multicast addresses. Solicited node basically, if you want to subscribe, you solicit for the address. Okay. Multicast address can only be destination address and not source address. Okay. Right, there are two types, assigned and solicited node. Two common assigned multicast groups are FF021 and FF022. The first one is the all nodes multicast group. Okay, so all IPv6 enabled devices will join this multicast, the first one. Okay, so if this communication happens, it's very similar to broadcast because all devices join, then the communication one to all. The second type is that exclude the host, only routers. This all routers multicast group. Okay, and this one is this group is that all the IPv6 routers will join. Okay, except the host. The first one, all nodes, including end devices, the host. Right. Well-known IPv6 multicast addresses are assigned and are reserved for predefined groups of devices. Okay, so this is what we discussed earlier, all nodes multicast group. Okay, a packet sent to this group is received and processed by all IPv6 interface on the link. For the all routers, okay, a router becomes a member of this group, and when it's enabled as an IPv6 router, okay, and then with IPv6 unicast routing, which we used earlier on in our practical, the moment you enable that, it becomes a member of this group. Okay, it becomes this multicast group member. Right. Solicited node IPv6 multicast. Solicited node multicast address similar to all nodes multicast address. It's mapped to a special Ethernet multicast address. So that means it works with the data link layer. Ethernet multicast address is basically the MAC address. Okay, the Ethernet NIC can filter the frame by examining the destination MAC address without sending it to the IPv6 process to see if the device is the intended target of IPv6 packet. So basically, if you're using IPv6 packet, the solicited node multicast address, when you send it inside the same link, the packet will be received by the switch, but the switch do not access network layer, right? But it doesn't matter because the two are matched. The multicast address at the data link layer with the multicast address at the IPv6, okay, it matched together. So the switch only needs to look at the destination address at the frame level. Yes, in the system multicast, there's multicast address at the MAC address level, so it will send based on that. It doesn't need to check the network layer, so it will still be sent to the correct host, right? Right. Further information allows Ethernet NIC to filter frame on destination MAC. So you can see here that each host will check, oh, multicast is not me, not subscribed, multicast is not for me. And this one is member, and then it determines, oh, this multicast, I can pick it up. These two will drop. Okay, it's not member. Okay. All right, so this extra information is basically for verification. Okay, ICMP version 4 is the ping for IP version 4. ICMP version 6 with extra features, right? Are meant for version 6 ping. Okay, but in terms of reply and request and reply, the echo, that means it's replying. You can use both, so this ping you can use to check whether host is online or not, destination is connected on the network or not, because based on the reply, whether the path to that particular host you're pinging is slower, so you can see whether the time exceeded means, well, of course something is wrong. But if the time it replies is slow, means latency, there's congestion on the path. Okay, and also can check route redirection. Okay. We have ICMP version 6 router solicitation and router advertisement messages. This one we talked about earlier on. Is part of the ICMP version 6 protocols. It actually means it contains the message. Okay, router solicitation and router advertisement basically meant for dynamically assignment of information such as IP address, gateway address, the DNS addresses, all this. Make use of this. Okay. Okay, the DAD also make use of this. So that means they have enhanced the ICMP version 6 to add this these services. Okay, ICMP version 4 does not have these features. Right, testing local stack means testing your own before you diagnose outside of your own host. You check your own self first, see whether your network stack is working fine or not. It means you are using the local host address. So 127.0.0.1 for IPv4 or colon 1 for IPv6. Okay, if you receive the reply of the ping, means your TCP/IP protocol stack is working fine. Yeah. Okay, you can do this for version 4 and version 6. Okay, testing connectivity on local LAN. You want to test either you ping your own host, I mean other hosts inside the LAN, or you ping the interface on your router, which is the default gateway. Okay, the address on the default gateway. So because you want to see whether you can reach the router, your default gateway, you ping that particular interface. Okay, to diagnose, if you say, oh, I'm trying to ping another remote host and you cannot receive any information. So basically, you want to see whether your own segment is correct or not, you ping here. If there's a reply, then you know this part of your network is fine. Then you can go to the router and start pinging from the router. Okay, just to check segment by segment. Right? Right. So I was explaining you can ping across a router. Okay, if it fails, right? Then you can ping from here to here, or from here to here, and you also can ping from here to here. That means you want to see which segment of the network is having problems. You can narrow down the cost. Okay, this is troubleshooting. One command you can use, and you can use this in your command prompt. Okay, is traceroute. Traceroute, you can traceroute to, let's say, Microsoft or Cisco, or traceroute to Cisco. It tells you the latency between your host and that host, and in between all the hops. Okay, all the routers in between. You can tell you. Sometimes routers are configured very nicely. It will provide information about itself. Okay, but some prevent hiding some information. When I'm doing this traceroute to Cisco, then I can see the interface on the router. So before I reach it, means how many routers in between me and Cisco server. So you can see one of the next router for me is the one belonged by my ISP. Excuse me, my ISP, right? And the latency is replied. That means every router receiving it will reply to me. So that's why I know what is the latency between me and that particular router. And then it forward to the next router and forward to the next router. So traceroute is good to make sure the path is okay, and also can detect is the path congested from me and all the way to the destination and between the routers in between. Yeah, this is one hop. So the traceroute program is able to provide that information for me. Now, if you use some of the more modern threshold software where it actually has a map of the world, because if you're doing threshold on the internet, okay, it can actually, if the router provide its geolocation, right? Okay, it doesn't hide its geolocation by its IP number. You can actually see the location of the router, approximate which country it is and which part of the country, and you can see the trace being conducted visually. All right, but some of the software is not free lah, of course, but some are free. You can try to find some online version, free version that you can trace through. All right, it can show you graphically the path taken, and of course all the information given there. All right, so we end. There's a lot of information. Hopefully, you guys can digest a little bit. Okay, let me stop my recording first. All right. Okay, if any questions so far? I think it's mostly a lot of theories and there's a lot of information concerning the format of IPv6. Okay, it's very important if you want to configure networks that is based on IPv6 to know the difference between different types of IPv6 address and how to how is some generated, how some of the link local address are generated, things like that. Okay, so right now is a little bit after 11:30. Now we are actually moving into tutorial. Okay, but we go for a quick break first, maybe about 10 minutes. You guys okay? I've already shared. If you notice in your, let me just share my screen for you quickly. Yeah. If you go to the tutorial section, you can see I already shared the tutorial. Okay, so you click that, you will see this. I already assigned. Okay, assign for tutorial. Okay, so later we will disconnect from this meet. We'll connect to the next meet. Okay, and we go for 20 minutes, 10 minutes break. 10 minutes break, is it okay with you guys? Okay, 10 minutes break. When we reconvene using the other meet, please open up this. I think I already shared. Excuse me. Okay, I shared now. And we'll do this tutorial. Okay, for 7 IP addressing. Right, so let's disconnect from this one and connect to the tutorial one, yeah? Right, guys? Kevin and Ferrer, for the compressed format, can you show rule 1, rule 2? Show rule 1 first and then rule 2. For example, let's say like rule 1, and then this one is rule 2 already. Yeah. Ferrer, can you do that also? Rule 1, remove leading, yes. For rule 1, remove leading. Okay, Ferrer. Compression, rule 1, remove leading zeros. So, yeah, adjust your answer for 1. Oh, how many bits in network portion? Question 8. The prefix is /30. Can you see that? The prefix is /30. So how many bits in the network portion? If the prefix is 30, for your subnet mask, yeah, so far you have 24. Continue 1 until 30 because /30, right? Yes, correct. So now you get the subnet mask for /30 network. 30 refers to the network part. So network part all ones. So that means leftover two bits is the host. So only 2 zeros at the back. Kelvin, question 9. You answer in dotted decimal format, not binary. Okay, but we need the network address. Okay, instead of IPv4 address, you write network address, but it must be it didn't ask for binary, so it's asking for the normal decimal dotted address, but we want the network address. So what is the network address for 172.30.188 with a default mask of 255.255.00? So it means you have to convert both IPv4 address into binary and default mask into binary, then perform the ending. So you get the binary network address value. And then you write it out in decimal. Okay. All right. That's correct. All right, guys, it's already 12:40. I don't want to take up any more time of your lunch time because I imagine you get class later. Okay. Anyway, you guys wake up very early this morning. So please continue to finish up this tutorial. I will check it. Okay, I will comment and mark it. Okay. All right, guys. Okay. All right, thank you for today. It's been a long hours, but you guys can go off for your lunch already. All right. Continue working on the tutorial as part of your homework. All right.